Hello dear students, welcome to Pen and Paper Chemistry on YouTube.
Hello dear students, welcome to part 8 of the topic thermodynamics. Part 8 is an extension of part 7 where we are talking about the different types of enthalpy that we shall be encountering in our study of thermodynamics, and this will be continued in part 9 as well, where we shall be talking about further different types of enthalpies. Before we go on to define the enthalpy and the different types of enthalpies, we need to talk about something important which is quite confusing for students many a times, and we are talking about the standard state. What is standard state? We know that different substances have different forms. So like oxygen exists as a gas, it can be found as a liquid, of course, under high pressure, and it also exists as an allotrope, that is ozone. Sulfur exists in two forms, sulfur rhombic, sulfur monoclinic. Enthalpies of these different forms are different. So when I want to calculate the enthalpy change for a reaction, I need to be specific which form of the substance we are talking about over here. Now, in my country, I would be talking about sulfur in monoclinic form, whereas you could be talking about the sulfur in the rhombic form. And we both keep saying that if we are talking about sulfur, we're talking about the oxidation of sulfur. But the values that we are getting are different. So the difference lies in the form that we are taking. So sulfur plus oxygen, if we simply indicate that the oxidation of sulfur or the burning of sulfur gives us sulfur dioxide, this equation thermodynamically is incomplete. Why? We have not mentioned the state of sulfur that we have taken over here. We have not mentioned the state of oxygen that we have to consider. We are not mentioning the state, solid, liquid or gas. In what form are we obtaining the sulfur dioxide, or in what form are we calculating this value? That is why standard state is something which we need to define. It is just like in physics, you define meter, you define gram, you define 1 second. What is 1 second? So when you say 5 seconds, that means it is 5 times of 1 second. So just like for any physical quantity, we need a standard over here so that the communication between the chemist, between the scientist is on a level field. So standard pressure for calculation of such values is taken as 1 bar or 10 to the power 5 pascals. Earlier in some old books, you will find it also written as 1 atmosphere. This has now changed. How do we represent the standard value? By a circle with a cross across it, or it is simply called as naught. Standard state. What do we mean by a standard state in thermodynamics? The most stable state of a substance in its pure form at 1 bar and specified temperature. Why is the temperature not fixed? Because the standard state of oxygen could be at 25 degrees Celsius, whereas the standard pure form of sulfur could be 0 degrees Celsius. The standard state of different substances is in the pure form is different at different temperatures. So we are not specifying the temperature over here. For example, if you consider iron, it is around 500 Kelvin. So which is very different from the standard state of water, which is liquid at 25 degrees Celsius. So you need to be very, very clear. But at this level, in most of your calculations, we shall be, when we will come across the temperature of 25 degrees Celsius very often. How does the change in temperature affect the enthalpy is to be studied much later in the topic. So if I have standard state of water, that is liquid, at 25 degrees Celsius and 1 bar pressure. Standard state of carbon is graphite, 25 degrees Celsius, 1 bar pressure. Standard state of oxygen, which is existing in 3 forms, gas, liquid, the allotropic form. So we have oxygen as a gas is the standard state for carbon. sulfur rhombic, sulfur monoclinic, hydrogen gas, hydrogen liquid. When it comes to solutions, we need to remember that when you're talking about the standard state of a solution form of a substance, we talk about 1 mole per liter at 25 degrees Celsius. How are we going to use these? You shall see further. We come to the next enthalpy, that is enthalpy of formation. What is enthalpy of formation? In general, if you have noticed in thermodynamics, we have been specifying the quantity because we know that enthalpy is an extensive property depending upon the amount of substance. As the name indicates, enthalpy of formation, or more exact, standard enthalpy of formation of a substance is the change in enthalpy when 1 mole of a substance is formed from its elements or substances in their standard states. These three underlined words hold a lot of importance in this definition. That is why I have stressed them while saying it also. Now let us consider an equation which is given to us. 2H2 plus O2 gives you 2H2O liquid. Now many of you would have already jumped saying that, oh, this equation is wrong. This equation as such and the value is correct. Because here, the notation that we have used over here is delta R H naught, indicating that I am talking about the enthalpy change for this reaction. How do we represent standard enthalpy of formation? As I said earlier, for representing a standard state, we'll put a not sign over here. You can just put a small 0. It will hold equally good. Delta is for the change, F is for the formation, H is for the enthalpy. So the enthalpy of formation, the standard enthalpy of formation of a substance is the enthalpy change when 1 mole of the substance is formed from its elements in standard state. First, let us check. Are we forming 1 mole of the substance here? Are we forming 1 mole of the product over here, which is water? No. We're forming 2 moles. So, this is completely out. Are we having the substances in their elemental form? Yes. Hydrogen and oxygen are the elements from which water is formed. Supposing water is formed as a byproduct in some complex reaction, then that will not be its enthalpy of formation. Are the substances, that means the reactants and products, in their standard state? Yes, they are. We noticed just now hydrogen gas, oxygen gas, water liquid. These are all three in their standard states. So the only objection we have over here is 1 mole. We are given a value which is for the formation of 2 moles of water. In order to justify the definition, in order to find the enthalpy of formation of water, what do we have to do? Yes, you are given the enthalpy of formation for 2 moles of water. So what will be the enthalpy, the standard enthalpy of formation for 1 mole of water? Simply use mathematical skills. If for 2 it is this much, for 1 it will be divided by 2, giving you a value of negative 285.8 kilojoule per mole. That means the energy change, the enthalpy change which takes place when 1 mole of water is formed from its elements, when all the reactants and products are in their standard state, is negative 285.8 kilojoule per mole. The negative sign here tells us a very important thing, that this is an exothermic reaction, a reaction in which heat is given out. In general, it's not a specific rule. In general, you will notice that substances which are formed by loss of energy are found to be more stable. Let's relate to us only. Supposing you are in a fit of anger, you're really angry over something. You are restless, you go around, right? When you cool down, you're more stable. You can think wisely. The same thing happens over here. When they are full of energy, then they are restless. They want to combine. When they lose that energy, they have formed something meaningful. They are more at peace. That was just a simple anomaly to make the topic lighter. We come back. The enthalpy of formation, the standard enthalpy of formation of elements is always taken as 0. Why? Because we are saying that the element has to be formed from its reactants in their standard state, from its elements. Now, this is an element in itself. So, what enthalpy will it be? It is 0. So, hydrogen, chlorine, nitrogen gas, oxygen gas, iron, metal, copper, silver, all these will be 0. This is a very, very important point and comes in handy when you go on to the numericals, which is the next heading I'm taking here. Standard enthalpy of reaction. Standard, so we'll put the naught sign over here, delta HR naught. The change in enthalpy of a reaction when all the reactants and products are in their standard state is simply called the standard enthalpy of a reaction. We've taken a very simple reaction over here. CaO plus CO2 gives you CaCO3. Let's link it to our first definition. We said enthalpy of formation. If you notice over here, we are forming CaCO3 solid. So does this value give me the enthalpy of formation of calcium carbonate? Think about it. You can write your answer on the side. No, it doesn't. Why? If you notice, we had underlined elements. When we are talking about the enthalpy of formation of a substance, we are talking about the reactants in their elemental state. These are not the elemental forms of calcium carbonate. So we have calcium oxide, carbon dioxide. These are both compounds. What will be the elemental states? That will be calcium, carbon, and oxygen. Coming to enthalpy of reaction for this particular reaction is given as negative 178 kilojoule per mole. How do we find out the standard enthalpy of a reaction? Simply, enthalpy of products minus the enthalpy of the reactants, all in the standard form, gives us the enthalpy change for a reaction in the standard form. If you notice over here, we are talking about per mole. Now, per mole doesn't mean that you are forming 1 mole of the product. This is simply because all your enthalpy values are in kilojoule per mole. In this particular reaction, this is the values that are given are as per the reaction conditions which are provided to you. Now, here I'm taking another example. I have been given 2 sodium reacts with 2 water to give you 2 NaOH and hydrogen gas. The state of the substances are given and we have been given the standard enthalpy of formation of water and standard enthalpy of formation of NaOH. Why not of sodium and hydrogen over here? Yes, because they are elements. We just now said the standard enthalpy of formation of elements is 0. So we go on to find out the enthalpy of this particular reaction. The enthalpy change during this particular reaction. Simply put, it is the enthalpy of products minus the enthalpy of the reactants. So, if you notice, in the products we have sodium hydroxide, hydrogen. So 2 times the enthalpy of formation of sodium hydroxide plus that of hydrogen, which is 0, minus 2 times the enthalpy of formation of sodium, which is again 0, plus 2 times the enthalpy of formation of water. Again, whenever I'm using the term enthalpy, it means standard enthalpy. So the enthalpy of formation of water, which is negative 285.8. The calculations become very simple. So 2 times of NaOH plus hydrogen, take away 2 times of sodium plus 2 times of water. Products minus the reactants. Now we simply have to put the values. So 2 times of negative 469.2. Remember, for the elements, you will make the enthalpy value as 0. Calculate and we get a value of, you would probably want to calculate it yourself. So negative 366.8 kilojoule per mole. If you like the videos, please subscribe to on YouTube. Let me know your feedback or any help that you need in any topic. Happy studying.
The only mission of this channel is to make learning chemistry easy and fun for all you students. With the help of the periodic table, the flowcharts, the graphs, diagrams, dealing with numericals, how to deal with numericals, and this can only happen when you keep a pen and notebook ready so that you can also take down notes for offline reference. There is no subscription to join the channel. There is no payment at all. Only request is to help spread a word about the channel by sharing it with friends, classmates, juniors, seniors, so that chemistry can be easy and fun for one and all. See you in the next video.